Okay, in this video I'm going to show how to import and then create toolpaths for cutting on a CNC router using Fusion 360. I have this new project in Fusion 360 called Jamie's Files. They're for my friend Jamie. And let's get started. So the first thing I'm going to do is I'm going to upload a file. I have off the recording screen, I have a file right here. It's a DXF called Poncho Stage Add-on 1. I'm just going to click upload, and you can see it's going to hopefully work. Give it a moment. Alright, it's uploading. That's good. I think the first half is it uploading, and then the second half is their server processing the file. This file is going to be cut on a sheet of plywood. I'm not exactly sure what thickness it's supposed to be, but I'm going to assume it's 3/4 inch. Alright, looks like it's finishing up over here. Alright, it's complete. So what we're going to do is we're going to open that, double click to open it, and if we're lucky, alright, yeah, we got some shapes in here. So what I'm going to do is I'm going to go to Model, and I'm going to, just to give a little bit of point of clarification here, this is a DXF file, so it's just a vector drawing. So I'm going to start by extruding, and I'm going to select a bunch of different regions. It looks like this one isn't closed. And we actually want to go 0.75 inches. Hold on, my numlock is off. 0.75 inches. Alright. And as you can see, we only got some of these here, so we're going to zoom into here and see what the problem is. It's not a closed loop for some reason. This looks like it's probably problematic. I don't know what that is. Alright, so I don't have a ton of experience with this aspect of Fusion 360. So let me see if I can do another extrusion. I wonder if I can put in a line here. Let's do the tangent arc. There we go, that's a closed section. Okay, so let's go to stop. Actually, we can extrude that. And again, we're going to go 0.75 inches. And just so you know, we can go over to units here and change that. Okay, so click OK there. Now, I'm not exactly sure why our extrude is different from these other bodies. But hopefully that won't make any problems for us in a minute. Alright, so we're gonna sketch here. We'll delete that. I don't know why Fusion decided to make everything grayed out. But we'll select here. Again, I selected the tangent arc. And we should be able to. Alright, stop sketch. Extrude this again. 0.75. Alright. And now these skulls here, we need to somehow, maybe if I go to front and I click here and I do extrude, actually probably what I want to do is I probably want to sketch, and I bet we can do a slot. For these eyes. It's not exactly what I'm looking for. Let's see if we can put this here. That looks good. Let's do another slot. Let's try this, if this works a little better. Oh, I did that wrong. The slot is rotated the wrong way. I don't have a lot of experience with this CAD package. Normally I work in SolidWorks, but that seemed to do it. Now, one of the problems with this nose here is that it's not quite going to give us what we want in terms of a cut shape, but we'll get to that later. If we do a spline, we might be able to select these points here. That's not really what we wanted, but we can try and modify it. Well, we can get a good approximation by doing this arc. If we do a 3-point arc, select here, go like that, do the same thing here, like so. That should work. Alright, and again, let's go with extruded. Now it should know to cut if we go negative. Okay, that didn't really work. Hold on. Let's say extrude. Cut. Negative 0.75. There we go. Alright. Now I'm not going to bother with this thing because this looks like it's the same exact head, and we'll deal with that in a second. I don't know why Fusion thinks that these ones are different from these ones. I don't have that much experience with it. I think it thinks that these are bodies and these are components, but I don't know. Anyways, the point of this was to do the cam side of things, so we're going to go right to cam now that we're 10 minutes in. As you can see, they're all here in the cam world, which is what we want, which is perfect. Again, I'm going to switch cam to inches, and then we're going to do a setup. So the first thing you do is you click new setup here. Actually, before I do that, I'm gonna save it, and I'm gonna say geometry, and that just means that I got my geometry all figured out. Alright, so I'm gonna do a new setup, and I'm just gonna go down these things one by one. So the first thing is to check the orientation. This is actually an okay orientation, but usually what I do is I select the Z-axis, which is the spindle axis, and I select any flat face, and you can see the Z is going in that direction, and then I select the X-axis. And in the case for this particular machine that we have set up, our X-axis is this one. Now, we want to think about the direction of the X-axis and how we're going to be cutting. Our machine has a little dust collector that comes off the, I guess it would be it comes off the Y direction, and it comes off the negative Y direction. So I want to think about my clamp placement when I clamp this thing down, and it looks like there's a little bit of space over here and space over here. So I'm going to actually flip the X-axis so that we have room for my dust collector. The next thing to do is select the origin. Our machine's origin is in the corner over here, and that's just a thing that I know from working with this machine a lot. Your machine may be different. And the next thing to do after we're done with all those is we go to stock, and this is going to be on a sheet of plywood. So it looks like the person who made this file, I actually didn't do this design, so that's why I'm running through this as the tutorial. Pretty much they laid it out pretty good for a sheet of plywood, so let's go with our width is 48 inches, and our length is 96, which is your standard sheet of plywood, so that gives us a little bit more margin on all the sides. I'm going to keep it centered. You can offset it a little bit, but this one's going to be fine to keep centered. Now the only difference is the height. The height I want 0.75, and I want to, you can see right here that it has the dimensions. If the part was a little bit bigger than 0.75, it would round up to the nearest half an inch, so it would round up to an inch. Sometimes I turn this down quite a bit to say 1/1000th of an inch if I just know that I want it to be exactly 0.75, but you can see right here that it's saying it's 0.75 right now. So click OK. That's our plywood size. Now the next part is to, I don't know why this model rotates, this particular model seems to rotate kind of funny compared to some of the other ones, but the next thing to do is to create our toolpaths. Now I have a really good workflow for that, but I want to show you the hard way so that you can see how to do it. For this, since we're just doing these 2D contours basically, there's two ways to do this. Since these parts are really simple, I'm going to focus on pocketing and contouring. So we'll start with the skull head here because that's going to use both. So I'm going to go to 2D pocket, and it pulls up this menu, and there's a bunch of different tabs, and generally speaking what Autodesk says is run through these. You start with the first tab and you go down, and then go to the second tab and go down. So that's what I'm going to do. So first, select the tool. We're going to be cutting with a 1/2 inch tool. Luckily, Autodesk has a lot of different tools. You can see they have this whole database. We're going to use a flat 1/2 inch end mill, so 1/2 inch flat end mill. I don't care about any of the other dimensions because our machine is a pretty simple, pretty basic machine, so I don't care about the length of the cut or how long it is overall or anything like that for this particular thing, but all that information is in here. it's here in theory. They have some preset spindle speeds, which we're going to override because we're using a router, and they're assuming that we're going to be using an end mill, which is technically a different type of machine, but not really. We don't have any coolant. You don't have to do anything with this, but we don't have any coolant. So if you have coolant, you can do it here. But alright, so spindle speed, we don't have spindle control on our machine, so you don't even have to touch this if you don't have spindle control through software, but we're going to be at 16,000 RPM because it's a router, again, and we're cutting wood. So if that sounds fast, that's because it really is. And all this other spindle speed stuff doesn't make that big of a difference for us right now. I'm not even entirely sure what a lot of it is because we don't have spindle speed control on our machine. But cutting feed rate, I want 200 inches a minute, and I just happen to know that for our tool. So this gives you this handy little calculator right here. This is actually the number that you really care about. This feed per tooth number is how much material is cut off for every time the tooth cuts away material. And right now it's saying it's a little bit more than 4,000ths of an inch. That's actually a little bit low for our tool. I know that our tool wants to have between 5,000ths and 8,000ths of an inch. That's information that you get from the manufacturer. But our machine is kind of a hobbyist class machine, so it's a little bit slower than some of the industrial machines. And routers spin really fast, so there's a couple ways to fix this. We could spin the spindle speed slower, but plywood tends to chip at lower speeds and splinter, so that's not, we don't want splintering, so we want the spindle to be going nice and fast. And we could go faster with the feed rate, but our machine has some issues because, again, it's a hobby class machine, so it's not really a fast industrial machine, so it can't really, I have cut up to 350 inches a minute with it, but it starts to lose a little bit of precision at that speed, so 200 is good for our machine. Basically this just means that we wear out our tools a little bit faster than we would otherwise. You can change all these lead in and lead out feed rates. I actually just keep them all the same because I want it to move along nice and fast. The only one that I do differently is the plunge, which I put at half of what the other feed rate is. Alright, so on to the next thing, which is the geometry. Now this is where we select our geometry, and we're doing a 2D pocket again, so we can select our pocket here, and I just want to point out that this little arrow right now, so it's putting this blue thing on the outside, which means it's actually saying that it's going to cut out the outside. So if we click this arrow, it creates it on the inside. Now I can select these other pockets right now, and I will do that. And this one is a little bit, I don't know how good of a job we're going to do cutting out this nose, but we'll see how that comes out in a minute. I don't use these options at all, so I'm not going to go into them. I tried rest machining once, but it didn't seem to do what I thought it would do, so I have no comment on that. I haven't gotten into these yet. I'm a bit of an amateur with this program, or maybe intermediate at this point. Anyways, moving on. So, heights. And this is the different heights for the tool. We have a clearance height, retract height, feed height, top height, bottom height, right? So, bottom height is currently set to the selected contour. You can, one of the things that I like is I like stock bottom. You don't have to change it because our contour should be at the bottom, the stock bottom right now anyways, but that just means that you're going to cut all the way down to the bottom of the stock with an offset of 0 inches. Top height is stock top, that's just when that's where it starts cutting. You could set that to other values, but stock, you always want to cut away the stock, so stock top is a great top height. Feed height, I'm presuming is 0.2 inches below the top height, which means that's where it's starting to feed. I don't know if the tooltips are pretty good in Fusion, so if you hover, you might get some good information from them. Anyways, the only one that I really use very often is the retract height, which I'll get to in a minute in the next operation. Alright, so let's go to passes. Very important for our machine. The tolerance here is an interesting one, and again, tooltips are great in Fusion 360. This can really affect a thing called data starving, and you can see that. I can't point with the cursor because it'll go away, but you can see that here, and that is a problem that I've experienced quite a bit at really fast feed rates with our hobby class machines. So especially for cosmetic things, you don't really need it to be that accurate, so you could really up the tolerance and then cut a lot faster without overloading or I guess I should say data starving your machine. Alright, so to move along, I always use conventional milling with our machine because it's not as stiff setup, and climb milling really requires a pretty stiff machine, so yeah, so let's see, finishing passes. Most of the stuff I ignore for the most part. Preserve order is really useful if you're cutting out multiple things and you want to specify the order. On this one I don't care. Maximum step over is how far the tool steps over. 0.475 is slightly less than the half-inch tool that we're using, which is great. Morphed spiral is good oftentimes as well, but I'm not using it right now because I know that I'm going to do multiple depths. I don't know what this is. I've never used it. It looks like something fancy, but I haven't used it much yet. Smoothing deviation, I also haven't really used this one much. It looks like that's something to do with the sharp corners. But that's for roughing passes specifically. So 2D, the pocket thing is considered a roughing operation by Fusion, so they have this stock to leave thing. This can mess you up. Basically, it thinks that you're going to do a cleanup operation after this, so I uncheck that because I almost always want my pockets to go to the full correct geometry. Alright, so multiple depths. I know that I want to use multiple depths on this one. So we go down about a up to 3/4 or 3/8 of an inch with our half-inch tool on this particular machine. That's just a number that I know off the top of my head and experience. But I put that at 3.32 to kind of keep it a little bit more even because I actually want to use a finishing pass. And the reason I want to use a finishing pass is because I want to have the very last step down to be 1/8 of an inch, which is a number that I've come up with experience with this machine, just wanting to leave a little bit at the very end. It really helps pieces from kicking out and creating other issues like jamming into the machine or things like that. Okay, so you see when I check this, I got a whole bunch of other options. My finishing pass isn't a true finishing pass, so I'm keeping the feed rate at the same feed rate and not changing any of these other numbers at the moment. I might double check that in a minute later. So I'm going to have one step down and then 0.125 for the step down. So this is 0.32 for the roughing step down and then 0.125 for the finishing step down. And alright, so we hide this, and this all looks good based on my experience so far, and no stock to leave. Some of the stuff you can play with a little bit, but I've tried to play with this a little bit, but I haven't explored it too much. So moving on to linking. This linking one is Not super important for what we're doing right now. However, it's important to note the lead-ins and the ramping can be very important if you don't have a center cutting tool. And I'm not going to explain what a center cutting tool is. You can look it up. Yeah, alright, so that's good for now. I do not like to keep the tool down. Alright. So let's click OK. Alright, so it generated our toolpath, and now you can see our toolpath. And right away I can see that it's doing something that I don't want it to do, which is it has this finishing step over on every pass. I don't actually want a finishing step over because that takes a lot of machining time. So I'm going to click Edit, and I'm going to go back to passes, and this is number of finishing passes. Maybe I want that to be 0. Maybe I want 0 finishing passes and only 1 finishing step down. No. I don't remember, and I'll show you why I don't remember in a moment. Maybe the step over will just be 0. Must be positive and non-zero. Alright, so let's do no finishing pass. Oh, right, okay, so no finishing pass, but we have a finishing step down. Again, I'll show you why I don't remember this off the top of my head in just a moment. Alright, so now it's generated the toolpath. You can see we get rid of that double line, and now it just has the 1 step down, 2 step downs, 3 step downs, which is exactly what I'm expecting for this thing. Now, another thing is this helix is really tight. I do like the helical lead-in, but it defaults to 2 degrees, so I like to make that 15 degrees with my center cutting tools, and then you just click OK, and now you can see it's a lot faster. Now I'm going to take this moment to go into the simulate, which is where you can see your toolpath. And I like to have stock so that I can see what it's going to do. And then you can just press play and it will show you how it's going to cut, which is a very convenient function and very helpful. And you can see that we cut out this face and the eyes, and actually the nose came out really well. We can see that it left a little bit of radius on the edges, and then we can click close on that. One thing that we can do is that you see that the toolpath goes to the sharp corner here. That might be something that we can fix with the where is it? There was a maximum cutting radius, or minimum cutting radius. So we can actually call that point. I usually use 0.26. It must be smaller than the cutter radius. Well, okay, I don't know what that is. Alright, never mind. I was hoping that I could get it to round that corner a little bit, but I don't know that I can. I'm sure it's in here somewhere, but anyways, we'll just ignore that. It'll be fine. It's not a big deal. It'll just, usually what happens is when the machine comes to a complete stop in a corner, it'll chatter a little bit. So there are ways to avoid that. I'm not familiar enough with the software to be able to get into that, so it's not something I'm going to go into right now. Alright, so that's our pocket. This warning here, you can click on the warning and it will say lifting feed plane to topmost ramp and lifting retract plane to feed plane. These are 2 warnings that I get with Pocket all the time. I don't know what they even mean. Clearly something about retracting the pocket. I bet it has something to do with the nose contour here. So if I click on this line here and then click the little trash thing, it might go away. No, we still have the warning. I don't know. I have nothing else to say. I don't know what that's all about. Okay. Now, what I can do is I can create a derived operation, and this is where I was saying that I don't remember some of the finer points of what I do because this is what really makes Fusion 360 fast, right? So I'm going to do a contour, and the contour should have the same tool, the same spindle speed, the same cutting feed rate. It shouldn't have, well, I guess it did keep the geometry, but we don't want the same geometry for now. It'll keep all this stuff. I want my retract height to actually be quite a bit higher because it's going to create a loose part, so I want to raise my retract height quite a bit. So I put in 2 inches. Passes, it should have all the same thing, conventional milling, finishing feed rate, step downs, finishing step down, everything here is looks good. And then, yep, everything looks good. Alright, so let's go back to geometry, and we're going to select this one, click OK, and now we can see that we have a toolpath already created really quick. We'll simulate to watch the full skull get cut out. Does all that. Does the eye. Does it again. Now you could do this with a contour, but then you'd have this chunk in the eye that could jam into your machine, so I usually pocket them. It's going to start here and it's going to cut around and do the whole contour. Looking great. Alright. And on the third pass, I don't know why that's going up and down right now. But there it is. Alright, that part's cut out. So, what I'm going to do with this is I'm actually going to create a let's see, save as, store as template. So I want to store this as a template. You can see I already have a bunch of templates, but right now I will say half inch, or I'll say contour, and then some descriptive word like half inch, right? So it's a half inch bit for a contour. Click save. I have a lot of derived configurations on this computer already, so that's just, I have to give it some name. I'll probably delete it in a minute. And then what I can do is I can right click on my setup and I can create from template, and I have contour half inch, and then I just right click on that and I click edit and then geometry, and I can literally select all of these and it will cut them all out, and I can click OK, and it will, okay, yep, and it will create the toolpath. Okay, so let's again look at our thing dead on. Now let's do simulate and watch it go. So it's going to cut out this piece first, and you can speed this up quite a bit to watch it go a little quicker. That's going to cut out this piece. I like how it's cutting out the piece in the middle first. I'm pretty happy about that. It's going to cut out that piece, which is good. And then this one. Very exciting. And that one. And then that one. Alright, it's good. I'm glad that it did it right here, because what you'll notice is that this is actually a really terrible spot to start the toolpath. So we have a clamp here, and we're going to clamp here, and maybe we'll have a clamp in this corner too. But this piece right here is almost completely cut out by the time it cuts out this piece, right? So you don't want to start and stop there because this is the material that's holding onto it, and it's almost completely detached from everything. There are some parts where it will even basically start on a loose piece of material. So you actually want to change that, and the way you do that is you go into your toolpath and you click linking, and you have entry positions. And this is where we can specify that we want our entry position somewhere else. So I'm going to select somewhere along this edge right here, and I'm going to click OK, and I'm selecting there because it is near our clamp. Basically, we want to be cognizant of the fact that as we cut away material, we will want to start near an area that has something stiff to clamp onto. As you may notice, all this is ready to go except for this skull here. I have a nice solution for that, so I'm going to control click on this second operation, and I'm going to go to pattern and linear pattern, and I'm going to select this face for the direction, and I'm just going to increase this until, let's say, 12 inches. Oh, that's really big, so we're going to go 24 inches, that's too much, and then we're going to go 18 maybe, 17 maybe. And it's interesting that it's not quite exactly lined up. I'm just going to assume that that's not a giant problem. Let's go 16.5. That looks perfect. Alright, and we're going to keep the original. And click OK. Alright. So now what we can see is that we have our setup, we have our pattern which cuts out the two skulls, and then the 2D contour which we have cutting out all of these. You can break this up into different operations. You would just create another contour. You can select the order with the preserve order thing that was here. Preserve order. So if you check this box, you can click these in the order that you want them to cut it out. Let's go back. Anyways, the final check is to click on setup. I like to look at it dead on. And when you click on setup, then you can simulate the whole operation. So I like to have my stock on, and we're gonna click play. It's gonna do the noses and the eyes, and then the face. Again, it's not perfectly lined up with the way they had it set up, but we're gonna get the same shape. Alright, now it's doing this one first. For some reason it changed the order, so that's a problem. Again, preserve order can be helpful. So let's go back and do our, we're just going to trash all these things because I want, oh, we can just click here, just click the X. Alright, so I want to preserve the order because I don't want it to try to figure out which one to do first. So I like to cut from the middle outwards because I know that I'm clamping the outer parts. So we're going to start with this one. I need to select, it is important to select the bottom one because it will try to cut out just the top one if you're not careful. So I cut out that middle one first, and then this middle one, and then we'll do this one here. And probably what I'm going to do is, so since I cut away this huge chunk already, I probably want to cut out this first, which leaves me, this whole thing is bridged along there. Now I'm going to cut out the bigger one of those two, or I should say the longer, the more slender one, because it's more likely to move when you're cutting. That one, and then this one, which will have a clamp right here. Maybe even we'll clamp it here too, so it's got pretty good support. So then we'll cut out this one last. And again, we'll go back to the linking and the entry positions, and we'll make sure that this one starts close to the clamp. and I'll just click OK, and then I'm just going to watch this one real quick just to see what it does. I don't really care where that first one starts. The second one, I do care where it starts. It's not a terrible spot. I usually like to start on flat, straight areas, but as long as I'm not starting here, it's not that big of a deal. Alright, it's going to go over here. I don't really care where that one starts. At least it starts in a good spot. I wouldn't want it to start over here. That one started in a good spot. I can see right now this next one's going to start in an awful spot. So we don't want to do that. So we're going to close this. Edit this again. You can do this more thoughtfully on the front end. I'm just going through the process so that you can see it. And let's edit. Actually, I'm sorry, we want to simulate again. Alright, simulate again. And we'll speed this up a lot. Alright, so go through that, go through that, go through that. Alright, perfect. Alright, close. Again, select setup to select the whole thing. Simulate. And watch it go. And it should all be good to go at this point. It's starting up at the top of the head, which is a fine place to start. Put out that one. And that's pretty much it. This one looks good to go. And it only took 40 minutes. Alright, so then the last thing that you're going to do, once you verify that the simulation looks good, is you're going to post-process. So you click up there. We use Mach 3 for our machine, but there's a lot of different things in here for different programs. I would call this Poncho 1, and you can save it to wherever you want. Mine's going to a Fusion 360 cam folder, but I might want to go to the desktop or whatever. The only last thing I would say is that for Mach 3, you want to turn use radius off. This one has caused problems for me before. It's on by default, but I always turn it off. And then you click post, and you'll get your file. So click save, and then now you can open it up in Mach 3 and cut it out. Alright, thanks for watching. Before I go, there's one last thing I forgot to mention, I think, and that's in the setup. And that's, I think I briefly skipped this, but when you select the box point, this determines where your Z0 height is. I select the bottom one because I want my Z0 height to be on the table. You might want it to be on the top of the material. So that's a little important point that I may have forgotten to mention earlier. Alright, thanks for watching. Bye.